All right, let's talk about part 2, solving systems algebraically. Today we're going to use elimination to solve systems of linear equations. First of all, you've got to warm up. I want you to pause the video and find the additive inverse of each term. If you can't remember what an additive inverse is, look it up very quickly, then come back and work the problems. Okay, when you looked it up, you notice that it's what you add to this term in order to get 0, right? Okay, so 4 is negative 4, negative x is x. 5x is negative 5x, and 8y is negative 8y. Very simple. Key concepts for today. Elimination is using the addition property of equality or use additive inverses to cancel a variable. Now there are several steps for solving systems using elimination. First of all, you need to put the equation in standard form. Remember ax plus by equals c? There's a reason why we learned standard form. Then we need to modify one or both equations so that a variable will be eliminated. You don't always have to do this step. Don't always have to do step 1. Sometimes it's already in standard form. Then you add the equations together and solve for a variable. Once you get a solution to one of the variables, you're going to substitute the variable back in to one of the original equations to solve for the other variable. So let's see what this looks like. So we're going to use the elimination method to solve this system of equations. Notice it's already in standard form. ax plus by equals c. So we can skip steps 1 and also skip step 2 because that's hard to say, isn't it? Because notice 3x and negative 3x are additive inverses. So if we were to align them up and simply add the equations, notice that our x is eliminated. When we divide both sides by a negative 3, we've got y is equal to negative 3. I would come back up here into this first one because it has less negatives and substitute a negative 3 in for y. So then we're going to add 3 to both sides. So we have 3x is equal to negative 6. So x is equal to negative 2. So we list it xy. So our solution is negative 2, negative 3. Example 2. Okay, look to see, is it in standard form? Yes, it is, so we get to skip step 1. But we've got a little problem. None of these would automatically, they're additive inverses, so we're going to have to multiply this first equation by 3, and we're going to multiply the second one by negative 2. And it doesn't matter, you could do this first one by negative 3 and this one by positive 2, as long as you can eliminate these two. Doesn't matter which order. So the m's will cancel out. We'll end up with 2n is equal to negative 6. So n is negative 3. Now come back into one of the original equations and substitute a negative 3 in for n. Looks like they picked the first equation, so m is equal to 4. So our solution is 4, negative 3. Let's try another one. First of all, is this one in standard form? Do we need to multiply by anything? We are. But this one's easier. We just multiply this first one by 2, and we end up with additive inverses. So we can eliminate the x. Look at there. We eliminate the y. We end up with 0 is equal to 12. No, 0 is never equal to 12. So this is an inconsistent system. There's no solution to this one. Very good. You are ready to begin the assignment.